All right, welcome back. So this is a ALEKS topic that's called calculating the heat of reaction from bond energies. I think this is a cool little topic. It's pretty straightforward, and it gets us to start thinking about what is actually happening in a chemical reaction. So I think that's a good thing to have in mind. So what we've got is a fairly simple little chemical reaction here, and it says to calculate the heat of reaction delta H for the following. And it wants us to use bond energies. You might look at this and say, well, why don't we use the formation enthalpies? And we could, right, if we had that information and we're looking for a delta H of formation. I think that's definitely reasonable to think, but this is telling us basically use the table of bond energies, and those should agree with one another. I haven't actually calculated it using the other system, but it should be similar, right? Okay, so let's go ahead and do this. So when we're doing this problem, what we need to think about is sort of what's happening when we do a chemical reaction. So to do this chemical reaction, we need to break some bonds. So bonds broken, we're going to break two HCl bonds. And so if I think about what's going on, we've got two HCl. This HCl, that covalent bond, we're actually going to break that. That's going to require energy. And one fluorine-fluorine bond. So this is energy absorbed by our chemical system. So, where does that energy come from? From whatever extra source we have, but it's going to require energy to break these bonds. Now, likewise, when we form bonds, energy is going to be released. So bonds formed, we're going to form two HF bonds and one Cl-Cl bonds. This is going to be energy released. So when we do a chemical reaction, every single chemical reaction, we can sort of imagine it's got two steps, and the first step is going to be breaking the bonds. So we're going to break these bonds so that they're separate from one another, and then that's going to take energy. And then we're going to reform some new chemical compounds. And when we form those bonds, energy is actually going to be released. We're going to be forming a more stable compound than when it's just all atoms. And then the difference between those, right, how much energy it takes to break the bonds, how much energy does it take, how much energy do we get back when we reform the bonds, that's going to tell us what the overall energy change is for a chemical reaction. So I'm going to use this data table. So, it says you can find a table of bond energies by using the data button. So if you click this data button, find these bond energies. So on this table, we should be able to sort of look up and find all of these different energies that we're looking for. So HCl, the amount of energy that is 431 kilojoules. Fluorine, that's 155 kilojoules. HF, it's over here, that's 567 kilojoules. And then Cl is 242. So, write down all of your bonds, then click on the data tab, then organize here. So now what we need to do is we need to say, okay, well, if each individual HCl bond requires 431 kilojoules and each fluorine-fluorine bond requires 155 kilojoules, what's the total amount of energy absorbed? So we're going to say 2 times this number plus 155. We're going to do the same thing down here and figure out, how much energy that is. Let me grab my notes real quick. So if you add this up, you end up with 1017 kilojoules absorbed, and you end up with 1376 kilojoules released. So I'm just sort of grouping together the amount of energy that's going to be absorbed and the amount of energy that's going to be released. And, 2 times 431, because I've got two of those HCl's, that's just my coefficient here, plus 155 should get you this 1017. Same thing here, 2 times 567 plus 242 should get you this 1376 kilojoules here. So then now we need to figure out, okay, well, if this is the difference, how do we sort of calculate? And we should just be able to sort of think about it and figure it out. If this is the amount of energy that's absorbed, this is the amount of energy that's released, we're going to take our energy from our bonds broken, and we're going to subtract the energy from that's being released. That's going to be the calculation or equation, you might say. So for this problem, delta H should equal minus 359 kilojoules. And that's it. So all of these problems are really going to be the exact same thing. Add up the amount of energy that is going to be absorbed to break the bonds, subtract the amount of energy that's going to be released from forming the bonds. The difference is our delta H for our reaction.